everyone! Here I will explain about errors and data analysis processing. The term error is based on the difference between the measurement result calculation value and the value received as the actual value. The true value of a measured quantity is something that is never known for sure. Errors in chemical analysis. The ideal analysis method is an analysis method that is able to offer practicality with few stages of analysis, of course with acceptable accuracy, precision and specificity values. There are three types of errors in chemical analysis, namely gross error, random error, and systematic error. Obvious error. Obvious errors are errors that are obvious because they involve major errors. Random error. Systematic error is an error that occurs systematically. Systematic errors, including 1. Personnel errors, 2. Operational errors, 3. These errors can be caused by less pure reagents, 4. Method errors. Error is the difference between the measurement result value and the value accepted as the true value. The error of the analysis result can be expressed in two ways, namely as an absolute error and a relative error. What is meant by absolute error is the magnitude of the difference between the analysis result and the true value. The range is the difference between the largest and smallest determination results. The smaller the difference, the more precise the result. 2. The average deviation. D is the deviation of each determination result from the average, regardless of the sign of the deviation, positive or negative. 3. Standard deviation is the square root of the sum of the deviations of each determination result from the average divided by its degrees of freedom. 4. The relative standard deviation, also known as the coefficient of variation CV, is a measure of relative precision and is usually expressed as a percentage. E. Significance test. A significance test involves a comparison between the calculated experimental factors and the factors already contained in a statistical table determined by a number of values from a set of experimental data and a selected probability level so that the decision taken is correct. This test compares the deviation of the measurement value that is suspected of deviating from the average measurement with the standard deviation of the sample measurement. The suspected value is the value that is furthest from the average. The calculated g-value is formulated with the equation.
Number 2 average test. This average test is related to the accuracy of the measurement results. In chemical analysis, there are usually three types of average tests that compare two values. In the average test, there are several types of tests, including A. Single sample t-test. B. Independent sample t-test. C. Paired t-test. D. One-way ANOVA test. Number 3, UG variant UGF. The variance test is used to compare the precision of two results. Methods.
How to write numbers. Writing the measurement result numbers or analysis results is essentially related to the accuracy and precision of the tool used. Writing the macro Barrett reading results with the smallest scale of 0.1 milliliters should be written with two decimals, for example 12.50 milliliters, and not 12.5 milliliters. Because by writing 12.5 it means that the number 5 is not certain, so that it can be interpreted that the titrant volume is between 12.4 milliliters and 12.6 milliliters. Whereas the number 5, which states 0.5 milliliters, can be read with certainty, stating the final results of quantitative analysis. The final result of a chemical analysis is generally stated by its mean. Of course, the mean is calculated after data analysis is carried out regarding whether or not there is any rejected data.
Linearity and regression. Regression is a curve that states the relationship between two quantities. This relationship can be a straight line or a curved line. In the second case, the linear relationship can usually be found in a certain way, for example by finding the logarithmic value. An example of a simple regression is the relationship between concentration and absorbance in spectrophotometry.